Welcome to this explainer for the Med Simplified platform. Today, we're looking at an absolute marvel of biological engineering, the human spine. Now, instead of getting bogged down in complicated, dry anatomy, we're going to keep it simple. We're going to break it all down using a really intuitive analogy. By the end of this, you're going to know exactly how this incredible structure keeps you upright, moving, and totally protected.
Let's jump right in. I want you to picture the vertebral column, not just as a stack of bones, but as a dynamic, living tower made up of individual building blocks. These blocks are stacked meticulously on top of each other. They support the entire weight of your body, but here's the magic. They still let you bend, twist, and move. It's just this perfect, delicate balance of rock-solid stability and total flexibility.
Here's our roadmap for today's explainer. We're going to cover the spine's building blocks, take a peek inside a typical vertebra, explore the neck and chest regions, move down to the lower back and base, and finally wrap up with cushions, curves, and functions.
So, to build this tower, nature gives us exactly 26 bones. That breaks down into 24 separate, distinct vertebrae extending right down from the base of your skull, plus two highly specialized fused structures at the very bottom, the sacrum and the coccyx.
Section 1. The spine's building blocks. We can divide the vertebral column into 5 specific regions. Up top in the neck, you've got the cervical spine, which is 7 relatively small bones. Moving down to your chest, we find the thoracic spine, made of 12 vertebrae. Below that, in the lower back, is the lumbar spine, with 5 large vertebrae. And finally, at the base, we hit the sacrum, which is 5 fused bones, and the coccyx, or tailbone, formed from 3 to 5 small fused bones. Oh, and a quick pro tip. Medical folks identify each block by the first letter of its region and its number position. So your topmost neck bone, that's C1. The third bone in your lower back, L3. Makes sense, right?
Section 2. Inside a typical vertebra.
Let's zoom in on the primary components of one of these standard building blocks. Toward the front or anterior part of the bone, you've got the body. This is the broad, flattened, frankly largest part of the vertebra. When you stack these blocks up, it's these flat surfaces that line up to bear the physical load. Then, right behind that weight-bearing base, you'll find the vertebral arch, which forms a bony ring at the back.
The really cool part is how all these pieces work together. The body takes the weight. Meanwhile, the vertebral arch, which is made of these bony plates called pedicles and lamina, creates a large central hole known as the vertebral foramen. And when you stack all 26 blocks together, those holes line up perfectly to form a protective, armored canal for your incredibly delicate spinal cord. Finally, jutting out from the arch, we have the processes. There are transverse processes on the sides and a spinous process sticking out the back. These are crucial anchor points for your muscles and joints. Actually, if you reach back and feel those hard bumps right down the center of your back, those are literally your spinous processes you're touching.
Section 3. The neck and chest regions. Now this is where we see just how incredibly specialized these bones can be. Let's look at the first 2 cervical vertebrae right at the top, because they're total outliers. The first one, C1, is called the atlas. It's essentially just a ring of bone, no real body, no spinous process. It just has these flat facets that cradle your skull, literally allowing you to nod your head yes. Right below it is C2, the axis. This one features a really unique upward projection called the dens, or odontoid process, which basically means tooth. The atlas sits right around this tooth, held tight by a transverse ligament. It creates a perfect pivot joint so you can turn your head side to side to say no. Pretty ingenious.
As we travel further down the neck, we hit the 7th cervical vertebra, C7. This one is actually famous enough to get its own special name, the vertebra prominens. It gets that name because it has a very long, straight spinous process. Seriously, if you reach to the base of your neck right now, that prominent bony bump sticking out, yep, that's your C7 building block.
Continuing down into the chest, we hit the 12 thoracic building blocks. Because they have to support a lot more body weight, they're noticeably larger than the cervical bones and actually have this distinct heart-shaped body. But their absolute most unique feature? Costal facets. These are specialized little articulation surfaces on the body and the transverse processes that connect directly with your ribs. This whole setup forms a sturdy, protective cage around your heart and lungs, prioritizing solid stability over extreme flexibility.
Section 4. The lower back and base.
When you compare the thoracic blocks directly to the lumbar blocks, the difference is honestly striking.
The 5 lumbar vertebrae are the true heavy lifters of the spine. They have these massive kidney-shaped bodies, and that's because they have to support the entire weight of your upper torso. They completely lack those costal rib facets, and their spinous processes become short, thick, and stumpy, which is perfect because they need to solidly anchor the massive, powerful muscles of your lower back.
Finally, we reach the foundation of our tower. The sacrum is a single triangular bone created by the fusion of 5 rudimentary vertebrae. Its job is to take all that weight coming down from the lumbar spine and distribute it outward to your pelvic girdle through the sacroiliac joints. And attached to the very tip of the sacrum is the coccyx, or tailbone. This is made up of to 5 small fused vertebrae and serves as the ultimate final anchor for your muscles and ligaments.
So, to tie all of this together, it's clear that the anatomy of these blocks directly dictates what they do. You see the body size progressively sizing up, from the tiny cervical bones to those massive kidney shapes in the lumbar region, just to handle the increasing physical load. We also see unique region-specific features popping up: transverse foramen in the neck to protect vital arteries, costal facets in the chest to hold the ribs, and those thick, chunky processes in the lower back for serious muscular stability. Form perfectly matches function.
Section 5. Cushions, curves, and functions. Remember earlier when I said the flat bodies of the vertebrae stack up on top of each other? Well, it's not actually direct bone-on-bone contact. Separating these bodies are intervertebral discs. These are tough pads of fibrocartilage. You can think of them as the shock-absorbing cushions, or the mortar holding our building blocks together. They're thinnest up in the neck and get progressively thicker as you move down to the lumbar region, absorbing impact and giving the entire column its flexibility.
Now, when all these blocks and cushions are stacked just right, another really vital feature appears. The gaps between the adjacent pedicles form what we call intervertebral foramina. You can think of these as essential little doorways. They provide a safe exit route for spinal nerves, blood vessels, and lymph vessels to branch out from the central spinal cord and travel to the rest of your body.
And our tower isn't completely straight either. A healthy spine naturally aligns in primary and secondary curves. We're actually all born with a single primary convex curve, but as a baby learns to lift its head and eventually learns to walk, secondary concave curves develop in the cervical and lumbar regions. This perfectly balances our weight over our legs. However, when these blocks fail to align properly, that's when we see structural abnormalities. Things like the exaggerated curves of lordosis and kyphosis, or the lateral side-to-side bend of scoliosis.
Let's do a quick recap. This masterful stack of 26 blocks performs absolute miracles every single second of your life. It provides a strong, bony, protective vault for your delicate spinal cord. Combined with those intervertebral discs, it gives you incredible flexible movement. It acts as the literal pillar supporting your skull, and it serves as the central axis of your entire trunk, anchoring your ribs, your shoulders, and your pelvis. It's the whole shebang.
So, as we wrap up this explainer, I want to leave you with a quick, totally honest question. How is your posture right this second? Are you slumped forward over a screen, or are you sitting up tall? Remember, the incredible biological engineering happening right inside you. You've got 26 dynamic building blocks perfectly designed to support you. Keep them stacked right and they will keep you moving. Thank you so much for tuning into this Med Simplified explainer, and keep learning.